Okay, so a little bit of substitution coming our way. So then F is equal to, so multiplying out, we have, let's see, 874 and 200ths. Integral from -3 to 3 of 9 minus y squared under square root times dy minus, now for this guy, we'll do a little bit of substitution. So I see a y squared inside and a y outside. U substitution might make things easier. If we let u equal 9 minus y squared, then we know that du is -2y dy. We've got the negative, we've got the y, we've got the dy, we're just missing the 2. So we'll multiply by 2 and by 1/2 here. So multiply by something worth 1. So we have plus 124 and 8600ths. Integral from, we'll talk about endpoints in just a second. I have u to the 1/2 times du. Endpoints though, if y is equal to -3, then u is equal to 0. -3 quantity squared is 9, 9 minus 9 is 0. If y is equal to +3, 9 minus y squared is also 0. Integral from 0 to 0, integral from a to a in general, you're talking about a rectangle with a width of 0. That will drop that entire piece out. So then our force is equal to 874 and 200ths times this part. We do learn a little bit more about how to do this with substitution later on. At the moment, they're just hoping that you recognize this as being the area of a semicircle with a radius of 3. So that will be times pi 3 squared. Semicircle, we have it over 2 then. So the amount of force on our circle ends up at 3,933 and 900ths pi pounds. All right, so I'm going to have one that I'm going to put up here. I'm going to have you all try it out and ask you to just sort of pause the video and give it a spin and see what you come up with, and then unpause it and see what we can do together. So we're going to have an isosceles trapezoid. Height of 4 feet with 6 feet at the top, 12 feet at the bottom, and the top is 5 feet below the surface. And we're going to assume the trapezoid is vertical, in other words, perpendicular to the surface. And remember that the weight of the water per density, 62.43 pounds per cubic foot. All right, so see if you can sketch that out and find the total amount of force. Go ahead and pause the video and come on back when you're done. Okay, welcome back. So for starters, our sketch, here is the surface of the water. And 5 feet down from there, top of our isosceles trapezoid is 6 feet across. Bottom is 12 feet across. And a height of 4 feet. So obviously, like many of my drawings, not to scale. All right, so we're going to put a coordinate axis on this. I found it easiest to put the bottom as the x-axis and center it on the origin. So 12 feet altogether for the bottom. So then we've got something happening over here at 6, 0, something happening back here at negative 6, 0. So there's the base of our trapezoid. 4 feet up, we've got the middle of the top piece of the trapezoid. And width of 6 feet, so 3 feet in either direction. And 5 more feet up, and we're at the surface. So our surface is at y equals 9. Okay, so now we have sort of a rough idea of what this looks like in an xy plane. So our depth, that's one of the pieces of the puzzle, which we label as height. Depth is 9 minus whatever y value we end up with. So for example, if we're at the top at y equals 4, we are at a depth of 5 feet. If we're down here at the bottom, height of 0, 9 feet altogether below the surface area. So our length, drawing our little rectangle here. Length is 2x, but again with a horizontal, we want that with respect to y. That means I'm going to have to figure out a little info about this line. So our slope of that line, 4 minus 0 is 4, 3 minus 6, negative 3. Slope of negative 4/3. And so then y minus 0 is negative 4/3 times x minus 6. So I just used the 6, 0. You could have done the same thing using the 3, 4. So then y is negative 4/3 of x. And negative by negative is a positive. 6/3 is 2, so plus 8. Clear the fraction, and 3y is negative 4x plus 24. So 3y minus 24 is negative 4x. So x is negative 3/4 of y plus 6. So now we can say our length with respect to the variable y is 2 by the negative 3/4 of y plus 6. It's a messy y there. We can do a little bit of simplifying as well. So negative 3/2 y plus 12. So our force, weight density, 62.43 pounds per cubic foot. It's the integral. We are going, our minimum y is 0, maximum y is 4. Depth, 9 minus y. And then our area of this little rectangle here, length times width, the width here being dy or delta y, and the length in terms of y, negative 3/2 y plus 12. So we can do a little bit of multiplying with that. So 462 and 43/100. Put the units on at the end here. Integral from 0 to 4 of, all right, so foiling things out, we have negative 27/2 y, we have plus 90 and 18, 108, and then we have plus 3/2 y squared minus 12y, all of that times dy. And just hit our like terms there. 12 is the same as 24/2. Alright, so we've got a little room here. F is now the integral. Make sure we can work here. Okay. 62.43, integral from 0 to 4 of hitting our like terms. So we had only one of our y squares, so 3/2 y squared. And a couple of y to the first. So we had negative 27/2 y. My apologies, I did not label that as a negative. Positive by negative is a negative. So minus 51/2 y plus 108 times dy. So now we're just using power rule again. So y squared becomes y cubed. So 3/2 times 1/3 is 1/2. So differentiate this. Half times 3 is 3/2. Third power becomes second power. Y to the first becomes y squared, so this is minus 51/4. So 2 over 1 times 1 over 4 is the 1/2 at the bottom, and there's your negative 51. And antiderivative of a constant is, as usual, first power. And we're grabbing those from 0 to 4, plugging and chugging from there, and we get, let's see, 62.43 by 260. So 16,231.8 pounds of force altogether on our trapezoid. Okay, so in section 7.7, I'd recommend 5 to 19 the odds and number 24. If you have any questions, please get in touch with me. Stay safe out there.